Welcome, everyone. Today we're diving into a sensation many of us know: getting a mouthful of ocean water. It's overwhelmingly salty, isn't it? I remember my first time at the Pacific, and I was shocked by the taste.
Absolutely, that salty tang catches people off guard. To simulate it, you could dissolve a few teaspoons of table salt into a glass of water. Take a sip, and you'll experience a flavor remarkably close to seawater.
It's a memorable taste, but just a quick safety reminder: drinking water directly from any natural source, including oceans or lakes, isn't safe due to potential bacteria and pollutants.
Right, that's why scientists often analyze water samples to ensure they're safe, using sophisticated tools to detect even trace amounts of contaminants. But let's pivot to the core curiosity. Why is ocean water so salty compared to other bodies of water?
If you've ever visited a lake or river, you've probably noticed the water doesn't taste salty at all. In fact, we call it fresh water. But isn't it curious that oceans are salty while lakes and rivers aren't?
That's an excellent observation. Fresh water in lakes and rivers usually lacks the strong, salty flavor of seawater, but interestingly, it's not entirely salt-free. Scientists have discovered that even fresh water contains minute amounts of salt, albeit too little for us to taste.
That's fascinating. So, when scientists study water from different sources, one of their first steps is to determine whether it's salt water or fresh water, using chemical tests and conductivity measurements.
Exactly. Those tests help categorize water sources and track environmental changes. But the real puzzle remains: what causes such a drastic difference in saltiness between oceans and inland waters?
For centuries, the source of the ocean's saltiness was a genuine scientific mystery. Early theories ranged from mythical salt mines beneath the sea to giant salt dumps. When did scientists start to crack the case?
It wasn't until the last couple of centuries that better tools enabled precise measurements. Chemists began identifying dissolved minerals, and geologists started piecing together how salt might accumulate over time. Yet, some details are still debated today.
It's remarkable how such a basic question could remain unanswered for so long. As technology advanced, we gained the ability to detect even the tiniest salt traces in water, which brought new insights.
Indeed, and these discoveries led to the realization that all natural waters, not just the ocean, contain some dissolved salts, though the concentrations vary dramatically.
Let's back up to where fresh water truly begins: rain. Is it true that rainwater contains no salt at all?
That's correct. Rainwater is essentially pure H2O because the evaporation process leaves salts and minerals behind. Even when rain falls over the ocean, those droplets are completely fresh.
So, rainwater is our planet's natural source of fresh water. But once it lands, the story changes, right?
Exactly. As rain hits the ground, it begins to pick up small amounts of minerals, including salts, from rocks and soil. This process is crucial in shaping the composition of rivers and lakes.
Once rainwater meets the ground, it starts to absorb minerals. Can you explain how this happens and why rocks and soil are key players in this process?
Certainly. Most rocks contain compounds like sodium and chloride, the building blocks of table salt. As water flows over and through rocks, it dissolves tiny amounts of these minerals, carrying them away in solution.
So, even the clearest mountain stream contains trace salts, thanks to this constant leaching. Is this process significant enough to affect the overall salinity of larger bodies of water?
Over long periods, yes. Although each drop picks up only a minuscule amount, the cumulative effect across millions of raindrops and years of erosion adds up, slowly increasing salt content downstream.
Let's follow the journey. Rainwater becomes slightly salty as it travels through streams and rivers. But if lakes and rivers remain mostly fresh, Where does all the salt go?
Great question. Most rivers and streams eventually flow into the ocean. While each carries only a tiny amount of dissolved salt, when you consider all the rivers worldwide over millions of years, the ocean becomes a vast collector of these salts.
It's almost like a conveyor belt, constantly transporting minerals from land to sea. And since the ocean doesn't have an easy way to release salt, it accumulates over time.
Exactly. Unlike lakes or rivers, which may lose water through evaporation but retain much of their salt, the ocean's sheer volume and lack of outlets mean salts build up, creating that familiar salty taste.
If rivers carry salt, why don't lakes become as salty as oceans?
Most lakes have outlet streams or rivers that let water, along with dissolved salts, flow out. This constant flushing prevents salts from accumulating to oceanic levels.
But there are exceptions, right? Some lakes, like Utah's Great Salt Lake or the Dead Sea, are famously salty.
Exactly. Those are called endorheic lakes, meaning they have no outlets. Water escapes only by evaporation, leaving salts behind and resulting in extremely high salinity, sometimes even higher than the ocean.
That's a perfect example of how geography shapes water chemistry in dramatic ways. Let's dig into the balance. Is ocean salinity constant, or does it change over time?
Great point. While rivers continually add salts, some processes remove them. For instance, marine organisms use calcium and other ions to build shells, and some minerals settle on the ocean floor. But overall, inputs outpace outputs, so the ocean remains salty.
Are there any long-term trends in ocean salinity? Could climate change or human activity alter the saltiness of our seas?
Climate patterns, like increased rainfall or glacier melt, can locally dilute seawater, while evaporation in hot regions can intensify saltiness. Long-term, however, the ocean's overall salinity is fairly stable due to the scale of these processes.
Ocean salinity isn't just a fun fact, it has real-world impacts. How does the saltiness of the sea affect ecosystems and human life?
Salinity influences ocean currents, which regulate global climate by distributing heat. Marine life also adapts to specific salt levels. Some species can only thrive in certain conditions, impacting biodiversity. Economically, salt extraction from seawater is significant in many coastal regions.
And let's not forget, desalination technology depends on understanding salt content to provide fresh water in arid coastal communities.
Exactly. As population grows and fresh water becomes scarce, efficient desalination becomes increasingly important, making ocean salinity a topic with far-reaching consequences.
As we wrap up, it's clear that the question, why is the ocean salty, connects geology, chemistry, ecology, and even technology. Are there still unanswered questions in this field?
Definitely. Scientists continue to study variations in salinity across different seas, how ancient oceans changed over time, and the potential effects of climate change. Curiosity drives new discoveries every year.
That's a great reminder to stay curious and keep asking question 7 about everyday phenomena like seawater. Thanks for this enlightening discussion.
Thank you. For listeners, keep exploring the mysteries around you. Sometimes the simplest questions open the door to the most fascinating science.